here what actually is like, if you just place, if there is no slab, see, I think if your realists are not understanding, okay, go back and analyze it. If a ray of light is incident, what do you expect central maxima? Central maxima will be here. Because where the path difference is 0, there should be the central maxima. There should be the location of central maxima. Where the path difference of the rays arriving at a point is 0, there should be central maxima will be here. When you bring a slab, what actually happens? When you bring a slab, when you place a slab, central maxima will shift above, no? Because when you place slab at upper slit, central maxima will shift above the axis. When you place the slab below the slit, central maxima will shift below the axis. These are the ideas. Now what I'll do is like, I will increase the temperature. Due to rising temperature, then the width of the slab will increase. Thermal expansion. And the central maxima will be brought to the again central axis. So there's a temperature theta 1, you write it. This what? If you are really getting confusion, at least analyze this much. Then you'll get an idea what to do. The thickness of slab is going to change. Here if it is T, no? Here it's a T, then become delta T. T plus delta T. Here you write thickness T1. Thickness of slab is here T1. This will be T2. Why? Because temperature got increased here. Now, what is our general method? So, some point here, point P, will write it equation. No? So what is the expression like S to S1P previous problem. Let me just go back here. Here I think somebody was asking doubt. Okay, fine. This will cover more path than this one. This will cover more path, this one. That's why the difference. Okay. Why negative sign they were asking? This one. No, come for this. So shall we write the equation? S2P path difference is equal to S2P minus S1P minus T plus mu T. So S2P minus S1P minus of mu minus 1T. This should be equal to dy by capital T. No, what is y is equal to this? So we are bothered about locating the maximus. Delta x equal to n lambda dy max by capital D. So what is y max is equal to? Let's come for this particular thing. What is this? This quantity is a shift, no? What is the shift? Shift is equal to mu minus 1 d will no. What is T? T is the thickness of slab. What all are going to change when as you rise the temperature? Due to thermal expansion, T will change. Due to again is telling delta mu cut minus gamma delta T. Because as y mu will decrease, the mu is directly proportional to density. As you rise the temperature, density decreases. The mu also will decrease. The both are going to change. Now, what should be the change in temperature so that it will come back to central maxima will be here. What is that change in temperature you should produce so that central maximum will come back to the axis? This was the question. So shall we now differentiate this? This will be d capital D derivative of t into derivative of mu minus 1, because small d already we're having, no, so don't write d there, you'll get confused here, plus mu minus 1 derivative of t. And derivative, this will become t delta mu, t into delta mu plus mu into delta t. Okay, so sorry, delta t, mu delta t minus delta t. Next part, okay, what is delta mu? Minus gamma delta t, I should write. Okay, this t equal to minus gamma delta t, delta theta. So this will become mu minus 1. Okay, I think I'll retain mu minus 1 only, unnecessary expansion. What is it? Delta t should be equal to alpha t into delta theta. Now what should be this shift should be equal to? The shift produced by, due to introduction of lamp, that shift produced by the rise in temperature should be equal and opposite. Then only open central maxima can return back to the axis. Minus t gamma delta t shall we equate both? Then we'll solve for the required thing. Okay, delta s should be equal to s. What is s? Mu minus 1 t capital D small d delta theta is what has to be determined here. Mu minus 1 capital D small d divided by, what do we get? Delta theta, no? So this will become mu minus 1 alpha t t gets eliminated, so mu minus 1 mu minus 1 alpha minus gamma, delta t will not be there. Okay, no, so this is the expression for delta t. Some mixed ideas. This should be the change in temperature. You can expect questions in advance of this kind in passages comprehension, no? Where they'll give information, then they'll ask you what can happen here. How many fringes has shifted down due to rise in temperature? So you can use this particular method. Okay, I'll end up the class. So try to revise all the wave optics. So many different types of numericals are there. I think directly with the help of numerical, revise all the basic ideas, so you'll be in a better position. Because in exam, finally what matters here, like the numerical analysis matters here. So the revision would have been better to revise through numerical.